Hello and welcome again to another edition of Lost in Science. This is half an hour of science on your listening device where we will talk about sciencey things. Who are we? Well, I'm Stu, and with me on the show, as always, I have Chris.
Hello.
And Claire.
Hello, Stu.
Now, Chris, I hear you have cooked up another home science experiment for us this week.
Yeah, look, it's been a while since we've had one of those. But I'm always looking out for stuff that we can muck around with, just like a simple home science stuff. This one, though, is a bit special. It's something that I've been interested in for a long time, and there happened to be a paper published recently that drew my attention to it. So I'm quite excited by this particular one.
Oh, give us a clue, Chris. What is it about?
Okay, this is the really important question of why does coffee spill when you're carrying a cup of coffee? And what's the best strategy to avoid? How do you avoid spilling the coffee, essentially?
Get a waiter to bring it to you.
Well, then you're just outsourcing the problem, I suppose. You know, you're not really solving it. You're just like moving it away. But yeah, no, this is something I've been wondering about for a long time. Back since I was a lowly physics student back in the 1990s. But as I said, there's been some work published on it. There was an important paper published in 2012. And another one was published a couple of months ago in 2021. So I thought I would look at those and see what science can tell us about what happens when you carry a cup of coffee. And you know what happened to try and stop it spilling, and I thought we could do a little bit of experiment and see if the predictions pan out.
Well, don't we just love a little bit of DIY experimental science? And Claire, what have you got for us this week?
Well, Stu, this is certainly not DIY experimental science. We have a guest with us this week, Dr. Linden Ashcroft, and we are going to be talking, I don't know if you know, I mean, most people have probably heard in some way or another that there is a big climate change conference happening in Glasgow at the moment, and it is the United Nations Conference of Parties, all about climate change and how the world can work together to mitigate the effects of climate change and to keep that change in temperature as low as possible. So Linden Ashcroft she's been on the show before. I don't know if you remember. Sometimes she comes and updates us on the IPCC reports. She's a climate scientist, and we're going to be talking about the climate targets, what each of the countries are bringing to the conference, and what I guess the climate science says about the different sort of like levels of heating and what that really means.
Well, fantastic. It'd be good to hear from an expert in the field about what they are going to be talking about at the big COP26, as it's also known. So that's coming up later in the show, so please stay tuned.
Okay, yes. Now, as I was saying in the introduction, this is a topic that I first got interested in when I was studying for my PhD in physics. As you can imagine, at that stage, I drank a fair bit of coffee, and I would, make my coffee in the tea room at the physics building, and then I would carry it back to the office to sit down and write some equations and things. And, quite familiar with the idea that the coffee would tend to spill while I'm carrying it. As a lot of people have noticed. And, I always wanted to figure out exactly what was going on with this spilling of coffee, because it seemed like there was some interesting physics there. But at the time, I was kind of more preoccupied with, the fundamental forces and particles of the universe and solving that, figuring out how all that worked. Spoiler, I didn't solve that either. But yeah, fortunately, since that time, there has been some work done on the coffee spilling problem. There was the seminal paper, Walking with Coffee, Why Does It Spill?
I mean, who hasn't read that seminal paper?
It's by Hans Meyer and Ruslan Krichetnikov from University of California, Santa Barbara. It was published in Physical Review E in 2012, and they modelled the basics of the process mathematically.
Did they do any field testing of their mathematical models, or did they just rely on the maths?
No, no. Okay, so first of all, they did some experiments with LED sensors to see when the coffee spilled, and then they did the basic equations of what's happening with spilling, and then they tried to model the whole system. There's actually a lot going on. Like, there's a person walking, obviously, at various speeds, and various things happening with walking. In fact, described in the paper what the process of walking is, which I thought was quite cute. And then there is coffee in a cup.
Can I just say, I just love physicists' approach to procrastination. It's like you procrastinate with more physics.
Well, yeah, look, it's fun. It's fun to do the physics and to figure some of this stuff out. And you can get a paper out of it. It's great.
It's prioritised procrastination, it's called. Yeah. Whatever you're supposed to be doing, you do something that's slightly less important, but you can still get work done. It's amazing.
Yeah. So anyway, look, there is a lot going on with this whole process, but one of the main things that you notice, one of the things that essentially that I noticed, but didn't actually mathematically model, which is that the liquid in the cup, it sloshes rhythmically. And the frequency of sloshes is very close to the rate that your steps go, which builds up resonance. So when you have, kind of a driving force that is similar to the natural frequency of an oscillator, which is what the sloshing liquid is, then it tends to resonate as it amplifies the oscillations, and eventually, in the case of the coffee, it'll reach where it spills over the edge. Mm-hmm. So that's kind of the most important thing that's happening there. So Meyer and Krichetnikov, they looked up some studies of sloshing liquids based on industrial processes, because people have, of course, studied, transportation of liquids and this kind of stuff. And they had a big formula that there's a few terms in there, but the main thing is that it is inversely proportional. The frequency, of the sloshing is inversely proportional to the square root of the radius of the container.
Okay.
You got me there? So it basically depends on the size of the cup is the main thing there. So I thought we would do a bit of experiment and test their prediction. So they, based on all this, they kind of looked at the fact that the frequency that you get from this cup is very similar to the frequency of stepping. And the result is that most people walking, it will, they predict there will be sloshing of the coffee within 7 to 10 steps. So I thought I might get one of you, maybe, Claire, if you're willing to volunteer.
I'm willing to volunteer.
To get a cup of liquid.
Oh, I have one right here.
Yeah. Now, first of all, could you, I wonder if you could give me the dimensions of that cup. Could you tell me how high it is and how wide it is at the top?
Absolutely, Chris. Let me just get out my tape measure. Yep, that is definitely the sound of a tape measure. Okay, so it is 9 centimetres tall.
Okay, thank you.
And then do you want the diameter of it?
I can divide by 2, yes, thank you.
9 centimetres tall and 8 centimetres wide.
Okay, so a pretty typical coffee cup. So that should have like the lowest frequency kind of resonance there, which is the most important one, is about 3.3 hertz. Okay, so 3.3 cycles per second. Okay. And average stepping is around about 2 hertz. Well, for myself, it's around about 2 hertz. It varies between like 1 to 2.5 hertz. So Claire, would you like to go for a little walk? Maybe down your hallway, and you can call out your steps and let us know when it starts sloshing. This is classic radio here. This is brilliant radio. Yeah. We are basically waiting for Claire to come back from her experiment and to tell us
18.
What happened.
18 steps.
18 steps. Well done.
18 steps. It started sloshing.
You've beaten Meyer and Krichetnikov's kind of equations there.
Really?
So well done. No, because they predicted like normally happens within 7 to 10 steps. Because actually, like I said, they did it based on some experiments and saw what happened, and then they modelled it. They kind of modelled the whole situation as a spherical pendulum and showed that they got from their model similar results to the experiments.
My cup isn't totally full.
Well, that is an important factor as well, yeah. So there is a few different factors, obviously, that will affect it, apart from the size of the cup. Yeah, certainly how full it is will make a difference with how much it needs to slosh before it will spill. There's also things like how quickly you accelerate. Like if you take off really quickly when you start walking, then clearly it's going to spill pretty quickly. And then also if you jostle it around, there'll be like chaotic behavior and stuff like that as well. But yeah, the normal behavior is that sloshing, and the thing is the normal coffee cup, as I said, like yours, is about 3.4 hertz. because the frequency is inversely proportional to the square root of the radius, the smaller the cup is, the higher the frequency is, and so it's actually less likely to spill because the frequency is further away from your walking frequency. So for myself, these days, I now mostly drink a long black, like a double espresso with a bit of extra water. So I have a small cup. And I take my own cup down to the coffee shop in the city when I've been working in the city. And I can happily walk around the streets with my little cup which has about a diameter of about 6 centimeters at the top, and not spilling anything really. So, that is certainly a method that happens there. Yeah.
So maybe we should take 2 cups to the coffee shop if you have a flat white, and get them to divide your coffee into 2 cups, so you have less of a chance of spillage.
You could try that. I'm not sure how amenable that will be. But look, I said they did some experiments on this as well, and to work out what actually happened. And one of the things they found in the experiment is that people who were focusing on the cup performed better than people who were just kind of focusing on where they were walking. So they thought in this paper that people might be suppressing the sloshing, but they didn't really get to the stage of analysing that. Which brings us to the recently published paper in September 2021 in the journal Physical Review Applied, which was called Synchronous Transition in Complex Object Control. It was by Brent Wallace, Ying-Cheng Lai, and other electrical engineers from Arizona State University. And they're interested in this problem from the point of view of robotics, because this kind of complex control is the sort of thing we do unconsciously, clearly. But it's the kind of thing that we need to be able to program robots to do. If they're going to take over our jobs.
Yeah.
And obviously, if we do want robot butlers,
yeah, exactly,
who can bring us our coffee, they need to know how not to spill it. I mean, that's a very important thing.
Now, in their paper, they liken suppressing the sloshing to balancing a broom on its end, where, you basically move your hand around to prevent the broom falling. So they found that they did a kind of virtual experiment. They found there are effectively 2 strategies people use. There's like a low frequency one where basically you move the cup in time with a sloshing, much like you might move your hand to match the broom's motion when it starts to fall. And then at a higher frequency, sort of transition to a different strategy, which is out of phase with the oscillations, so to try and dampen the oscillations. So this is kind of relevant to another experiment I did. I'm not going to replicate here in front of you because I need to get up and walk, and as we discovered, that's not the most scintillating radio. And this was I tried to find a receptacle that's even closer to my step speed and to see if it spills faster. So it has to be about 21 centimeters across. So I found a large bowl, filled it with water. And certainly if I just carried it walking without looking at it, it spilled very quickly, because the natural frequency of that is basically the same as my step frequency. But if I was more careful and I watched the bowl, then I could keep it going for much, much longer. It's basically carrying a bowl of soup kind of thing. You can carry a bowl of soup quite effectively. And so to me, this seems to match this broom analogy. So when the broom head is at the top, it's very unstable, but it falls very slowly, and you can have a lot of time to compensate by moving your hand, which is why you can keep it balanced for quite a while. So similarly, when you have a big bowl, it oscillates at a lower frequency, which means it's very visible. So you can watch it and you can go, oh, it's sloshing, I'm going to move that and compensate for it. And so you can actually carry it for quite a while without spilling anything. So this is the other strategy. So yes, you can use a smaller cup or 2 smaller cups if you're going to have a flat white. I don't see why you can't have a black coffee. To me, it is better. It's more pure to the taste of the coffee, but that's a discussion for another time.
That's a discussion for another time, but I want that discussion.
Yeah. The other option is having a much, much larger cup, maybe 20 centimeters across at the top, like one of those big French bowls. But either way you do it, watch, if you're only going a short distance, watch the cup rather than your feet, because then that'll help you compensate the oscillations and you reduce spills. You just basically make sure you don't bump into anything, I guess, because that will clearly make it spill pretty quickly.
Coffee on radio? Not so sure about that. Coffee and TV maybe go together a bit better. This is Blur.
So the United Nations Climate Change Summit, or COP26, is happening right now, bringing together leaders from around the world to make a commitment to limit the warming of our planet and catastrophic effects of climate change. Of course, there will be a lot of politicians and world leaders at this event, but I reckon it probably needs a few more climate scientists. That's why we have with us today the inimitable and very clever Dr. Linden Ashcroft, lecturer in climate science and science communication at the University of Melbourne and friend of the show. So perfect guest to lead us through everything to do with COP26 this week. Linden, welcome back to Lost in Science.
Lovely to chat to you again, Claire. Great to be here.
Okay, Linden, let's start at the start. There's a lot to talk about with this climate summit, with COP26. First of all, it seems to have, as it should, a lot of people are talking about it. Why is this one so important?
I think COP26, so it's the 26th time the world has met to discuss climate change, which should give you, an indication of how long this conversation has been going, much longer than it should be, really. To me, I think the timing of this event is crucial for a couple of reasons. First of all, this is the first time that the nations have met since 2015, when the Paris Agreement was set, and that is when all of the countries around the world decided to pledge to keep global warming under 1.5 degrees or 2 degrees, but ideally 1.5 degrees. And that means heating up the planet and adding enough energy to the atmosphere and the oceans for the Earth to heat up 1.5 degrees, the whole planet heat up by 1.5 degrees higher than pre-industrial levels. So about the 1800 to 1850 average temperature, 1.5 degrees warmer than that. And we're tracking at about 1.1 degrees warmer now.
Right now.
Yeah, right now. Australia is 1.4 degrees warmer than it was at the start of the 20th century. So this is the meeting now where those pledges and those lofty goals are kind of being really interrogated, and they're really being put under the microscope. Lots of countries have made goals and made plans, but COP26 is when I think nations are coming together to kind of scrutinize each other's and really make sure that they're going to be held accountable for the pledges and the plans that they've made. For me, I've been thinking as well about the importance of the timing of this discussion in relation to COVID. This event was actually supposed to happen last year, but it got delayed by a year because of the pandemic. And now we're seeing things opening up. We're seeing travel being freer than ever. We're seeing all of these things. And there was a slight decrease in the amount of greenhouse gases that were emitted in 2020. I think there was about a 7% drop in greenhouse gas emissions across the planet.
I mean, everyone was saying it was almost like a silver lining. It was like, well, it's a pandemic, but at least emissions will go down.
Yes, but nowhere near enough. And the literature I've read about it has said that that's how much we need to reduce emissions every year if we're going to keep ourselves under that 1.5 degree target. And so now, particularly in Australia, and things are opening up and people are justifiably wanting to plan trips, wanting to see family, wanting to enjoy freedom again, I think there's a risk of bounce back and everybody kind of of overshooting again, and all of those gains, by gains I mean emissions losses, will be lost, if that makes sense. So I think the timing of this is quite crucial from that aspect as well, to kind of think about, wow, we've just spent the last 18 months doing really difficult stuff, living a very different way to protect people, and these decisions about what we're going to do now to reduce the worst impacts of climate change, that's also going to mean some big decisions being made. And while the thought of jumping from one set of restrictions to another set of restrictions, that's not what I mean. I guess it's just an opportunity to stop and reflect and think about how much this place really means to us and what we're going to do to look after it.
You mentioned a little bit about the global targets there. I mean, this COP26, it is over 150 countries coming together, right? There's lots of different sovereign nations represented at this summit. Globally, what are the sort of targets and expectations of targets that are being discussed?
From my understanding, there's two main sets of targets to be discussed, as well as some other ideas about money and also adaptation and how people and countries are going to adapt to the amount of global warming and climate change that is already here. But from my understanding, there will be talk about short-term targets. So by 2030, what nations are pledging to do by 2030. And then sort of middle term targets by 2050. Like 2030, it's less than a decade away. You know, I might still have the same pairs of pants in my cupboard by 2030 than I do now, you know. That it's really not that far away. And 2050 is also really not that far away. And so what I understand the countries are looking for now is really turning those big pledges into genuine, this is how we're going to do this. This is a path to get from A to B, to get to this kind of reduction by 2030 with a goal of getting to net zero by 2050. I think that is the goal of quite a few countries. We've heard that's the goal of Australia, but you can't just say, okay, we're going to get to net zero emissions, which, you know, means that the amount of carbon dioxide that we do emit, or greenhouse gases in general, not just carbon dioxide, will be counteracted by either pulling greenhouse gases out of the atmosphere or reducing it all the way down to zero. You can't just do that in 2048 or 2049, you know. So the quicker that we can plan and make a strategy, the better it will be. If you think we've got to go from a high value all the way down to zero, if you do that in a short amount of time, that will be a pretty rough ride, right?
Yeah,
that will be
that is a steep curve.
Exactly. That's a pretty dramatic roller coaster.
Yeah.
Whereas if you start that transition now, then it will be a much more gentle ride, I would say.
Sure. And targets are there to keep you accountable.
Exactly. Yeah. And real targets as well, because I think particularly in Australia, we've had so much uncertainty about this topic for so long. Will they, won't they? Is there a price on carbon? Is there not a price on carbon? What's the government going to say about this? What's the government going to say about that? And that really paralyzes other ways that we can adapt as well. So industry can't do much with that. You know, businesses, that uncertainty just really stymies any kind of development or any kind of innovation, I think, because if you don't know whether the government's going to support it, then you're probably not going to jump at it, right? Which to me is a real shame. It's a real missed opportunity that we've had so many missed chances to make the most of this transition to a green economy. And so I'm hoping, although we haven't heard a lot of promising news yet, but I'm hoping that Scott Morrison's attendance at COP26 will lead to some clearer targets for us and some certainty. We know that we're getting that from our local governments, you know, from our state governments. Every state has, I think, got a much clearer path to net zero, but it's just the federal government that needs to hurry up and get on board.
You were talking about the Paris Agreement before and keeping warming to, you know, 1.5 degrees or, you know, thereabouts. I mean, thinking about it, you know, 1.5 and 2 degrees, it might not seem like that much of a difference between those two temperatures. From a climate science perspective, what does the scientific modelling sort of show around this difference?
Yeah, these limits have been studied a lot, and there's been a lot of research as to what those two futures would look like. The difference between 1.5 degrees and 2 degrees, I think, is the difference between 10 million people being displaced and 10 million people not being displaced. 1.5 versus 2 means we might get to save a bit of the reef versus we absolutely won't get to save any of the reef. The other thing to realize about these targets is that there are values in between, right? So we're already seeing an increase in heat waves. We're already seeing stronger hurricanes in the North Pacific. We're already seeing more intense rainfall events. We're already seeing changes in the weather patterns across southern Australia. We're already seeing climate change affecting every single country and every single continent all around the world. And shifting from 1.5 degrees to 2 degrees means an increase in the frequency and intensity of these really extreme weather events that have the big impacts. Because you're right, that shift of 0.5 degree in the global average temperature doesn't sound like much. And, you know, it's a metric that feels really far away. You can't touch it. You don't really get it. You're like, yeah, I would like my days to be 0.5 degree warmer. That sounds great. But it's shifting everything, right? It's shifting all of those tail ends of the distribution. If you imagine all the weather events lined up from coldest to hottest, from wettest to driest, it's shifting all of those. And it's changing the behavior of so many of them. And so it's not just, okay, if we can't go to 1.5, we can go to 2. We could try 1.7 or 1.8. Every 1/10 of a degree of warming makes those extreme events a little bit more intense, gives the whole system a little bit more energy. Australia is the most vulnerable developed country when it comes to climate change because we have such an extreme climate. You know, we get buffeted by the temperature patterns in the Pacific Ocean, in the Indian Ocean. We get the tropics can affect us, obviously, up in the tropics. And then down in the southern parts of Australia, we get Antarctic weather systems. We get it all here in Australia, which is amazing. But as you know, our weather is just notoriously dramatic, and climate change is only going to make it more dramatic. And so everything we can do to limit getting to that 2-degree threshold, or even higher and higher, will make a difference.
So given Australia's susceptibility to, increased fires and extreme weather events, and everything to do with climate change, it would sort of make sense that our targets should reflect that. Are we doing enough? Should we be doing more? And what should that be?
Well, it's probably no surprise, given the discussions that have been on the news for the last weeks and months and years, even through COVID, the talk about climate change hasn't gone away because we've still been exposed. There've been devastating heat waves across the Northern Hemisphere this summer just gone, and we've had floods in Victoria. We've had, storms. We've had so many weather events happening, and the fingers of climate change are on so many of those events now. And you're right, I think Australia needs to have a really strong target, but from what I can see, we don't really have enough yet. We're not really making the most of this opportunity. We've got so many incredible resources in Australia. I'm not just talking about solar and wind and hydro, or, I'm not talking about those, only about those renewable resources. I'm also talking about the incredible intelligence and innovation that we've got in Australia. We've got so many smart people here, smart farmers, smart scientists, smart engineers who are thinking about incredible ways to address this challenge, address this crisis. I teach master's students how to communicate their work better. And so many of the incredible projects I hear about are about tackling climate change in one way or another, whether it's smarter farming, whether it's new technology, whether it's developing heat-resistant coral, whether it's studying past climate, whether it's studying how past Indigenous communities lived in various climates across Australia. There's so much incredible knowledge and momentum within Australia and within the communities. I think, I don't know about you, I feel like the momentum has shifted and people are just ready now. We're just ready to crack on. We are ready to just do it. We know that we've got to do it. We know that we have to do our very best to reduce the worst impacts of climate change. We have got absolutely no time to waste. And so it is a bit disappointing to see that the targets that have been suggested by the government are really wishy-washy and hand-wavy and quite vague and relying on technology that hasn't been tested yet or hasn't been proven. It's kind of kicking the can down the line a bit, where we've already kicked it a pretty long way. The latest Intergovernmental Panel on Climate Change report was released a couple of months ago, and the language in that is terrifying and brutal. It is unequivocal that the world is changing. It is unequivocal that it is us. It's happening, it's bad, and it's us, and we need to do something about it. So the targets that we have now, a really long-winded way to answer your question, the way that I see it, the targets that Australia has put forward now are not strong enough. They're not strong enough to deal with the issue, and they're not strong enough compared to what's being suggested in other places around the world. The US is suggesting stronger targets. The UK has got a really clear, strong plan. Lots of places across Europe do as well. I think China is also making some strong plans, and hopefully Scott Morrison's time in Glasgow will convince him that he can join those ranks as well.
Well, on that emphatic note, Linden, thank you so much for joining us today. There will be an election, no doubt, pretty soon, and everyone can exercise their right to vote for a party that's got a climate change policy that, heeds the advice of climate scientists like yourself. So that's really good to remember. And thank you so much for leading us through the COP26 Climate Change Summit. Thank you so much.
Thanks for having me, Claire.
That's all we've got time for on this episode of Lost in Science. Thanks for tuning in and joining us. Lost in Science is recorded at the studios of 3CR in Melbourne and broadcast across Australia on the Community Radio Network with the financial assistance of the Community Broadcasting Foundation. If you want to talk back to us, you can get in touch. We have a Gmail account, lostinsci@gmail. You can also find us on Twitter and on the Facebook. And if that's not enough Lost in Science for you, you can always tune in again next week, where the team will once again get Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.